All right, so let's get down to business. How do we actually use these difference equations? So we've talked about that subscripts are heavily involved. We need to know how to work around subscripts. And we've also gone through the idea that it's basically a rule defined through mathematical symbols, which we can also interpret using English. And it's using those two ideas together that we're going to use to actually solve problems. Okay? So the first thing I want to highlight when we're solving difference equations, okay, is that you want to think about that English translation. So when you see a difference equation, do just have a quick think, okay, well, what is it actually saying to me? So that when you start playing around with it, you can have an idea that your answer is reasonable. Okay? And then the kind of big idea process, just not cooperating, there we go, is that what we want to do is we want to fill in subscripts. Okay, so if we've got a particular value of n that we're looking for, fill that in, and then fill in any values that you're given, and solve by either working backwards or forwards. So there will be a little bit of algebra involved, but of course we do have the finite solver to help you, or sorry, sequence solver to help you generate sequences. So you can use basically the spreadsheet to create a long list as defined by the difference equation. But we do want to also be able to use algebra to solve these questions. Okay. So starting off here, we're diving in fairly promptly. I've got a difference equation. I've got the two really important components. I've got basically a place to start. I'm starting with T4 is equal to 15, and I've defined it here, okay, that Tn is equal to Tn minus 1 over 3 plus 4. Okay, so this was actually the same example I used earlier. So again, thinking about that English translation, well, this first bit here, okay, T4 is equal to 15. That means that the fourth term is 15. And then this bit here, okay, my actual rule is that to get the current term, I take the previous term, divide it by 3, and then add 4. So we're going to use that process to help us find some values. So our goal, the question says, is to find T6, but it gives you a little hint by first finding T5. Okay, so note if I was to just try and find T6 right away, well, it's always defined as the previous term, so to find T6, I need the term before that, which is T5. So I have to find that first. So let's give it a go. Okay, again, you can use your CAS to help you out here by filling in the values for, so if you're looking at a question like this, your D is 1 over 3, okay, because you're dividing by 3, or sorry, let me correct that, that's not correct. Your R is 1 over 3, and your D is 4, okay, because you're dividing by 3 but adding 4. So you can use that in your CAS to help you, but here's the kind of overall process. Well, I want to be able to find the next term, so I'm not overly focused on T4. I already have that. I want to find T5, so I pop in T5. Well, T5, again, if I put 5 in for that n there, I'm also putting 5 in for that n there, meaning this is T4. Okay, because if I put 5 in for that n, I'd get 5 minus 1, which is 4, over 3 plus 4. Okay, so that's filling in my subscripts. Then I fill in any given term values. Okay, so do I know what T5 is? Well, no, that's what I'm looking for. Do I know what T4 is? Absolutely, it's sitting right there. T4 has the value 15. So T5 is 15 over 3 plus 4. So that means that T5 is 5 plus 4, or T5 is 9. Okay? So now I've got the fifth term, so I can use that to find the sixth term. Take a moment, try and find that sixth term on your own using the same process. So T6 is again what I'm looking for. Well, that's T5 over 3 plus 4. Again, the reasoning for that, whatever value I put in here, that subscript needs to be 1 less. So in that case, T6 is equal to T5. Well, what's T5? Oh, it's sitting right over there. 9 over 3 plus 4, which is 3 plus 4. So T6 has the value of 7. Okay, so I've accomplished the question because it did ask me to find T6, but I needed to find T5 first. So that's the idea with difference equations. Again, these are lovely things, but if I had asked you to find, say, T100, well, to find T100, you need T99. To find T99, you just need T98, and you see how these can be less effective, which is why they have those general solutions, which are oh so pretty formulas, so that we can find it in terms of n. So that's kind of your foundational how do difference equations work. Okay, we do want to be aware of kind of algebraically how do they work. Okay. Now here's another example. I've changed up the subscripts a little bit just to, again, push that comfort zone a little bit. So instead of defining it in terms of Tn, I've defined it in terms of T sub n plus 1, which is completely fine, because again, all subscripts are is a reference point. So what this says, well, this is the next term. Well, how does Tn compare to Tn minus 1? Sorry, n plus 1? Well, it's just the term before it. And then this is the term even before that. So again, going back to that key idea, what is this really saying? Well, these two terms are just the two terms directly before Tn plus 1. So all this is saying really is add the previous two terms. So Fibonacci sequence, again, a second order difference equation. I'm just pushing your comfort zone a little bit. This means the exact same thing as Tn is equal to Tn minus 1 plus Tn minus 2. And these two rules mean the exact same thing because it is just a reference point. Okay, so this one's a little more challenging. Here I want to find T8. Okay, so again, to find T8, T8 is defined as the sum of the previous two terms. Okay, but I haven't given you the previous two terms. I've given you term 5 and 7. It's a little bit obscure. So let's kind of break it down. Well, if I wanted T8, okay, again, what this difference equation means is I add up the previous two terms. Well, what's the term before T8? Well, that's T7. Ooh, I have that. Okay, that makes me happy. But it's plus T6, which I do not have. So I need to somehow figure out what T6 is so that I can use this equation to find T8. So I'm just going to put this on hold. Okay, so that equation's on hold for now until I can figure out what T6 is. So here we go. How do I find T6? Okay, so notice this equation involves 8, 7, and 6. Well, I've got T5 and I've got T7 and I want T6. So if I wanted to set up a similar type equation that involved term 5, 6, and 7, well, term 7 is term 6 plus term 5. Okay, using the same idea that what this really means in English is that I add the previous two terms. Okay, or thinking about filling in if this has value 6, that guy has to be value 5, and that one has to be value 7. Now, I do have term 7, and I have term 5. So if I've got an equation with only one unknown, I am happy to solve it. So I put in what I know. Well, T7 has value 5, so the 7th term is 5. I don't know the 6th term, that's like my x, my unknown. My 5th term is 2. Getting back to good old algebra, again, you can use solve on the CAS, but I really don't recommend it here. just subtracting 2 from both sides to get that to cancel out and to leave me with t6 all by its lonesome. So the 6th term actually has value 3. So again, this means the 6th term has value 3. Well, now I've got t7 and t6, so I can go ahead and fill in and actually do what the question asked me. So let's fill them in. Well, t8, that's what I'm looking for. t7 is 5. t6 is 3, meaning that t8 has a value of 8. Okay, pure coincidence. So my sequence would look something like 2, 3, 5, 8, okay, which you may recognize as a Fibonacci-like sequence. So it was adding these two to get the next one, adding these two to get the next one. So story does check out. It is always important to make sure that your answer is reasonable. So do a quick check. Now the last bit is just kind of a little bit more of how do we use these difference equations. So it works both ways. You can be given the rule and asked to find terms, or you can be given terms and asked to find the rule. So here I've given you the sequence 3, 5, 7, 9, and I want you to write a difference equation to represent the sequence. Now again, you can write it in a few different formats depending on which you prefer. Okay. Personally, I prefer starting with my rule, starting with Tn, but you can start with Tn plus 1 as well. So, first of all, think in English, what's happening here? Well, you start at 3. How do I get to the next term? Well, every step I go up, and then we're adding 2. So that's my rule. So there's my starting, there's my rule. I just need to translate that to math, and I've got myself a difference equation. So let's start with the rule. Well, to get my current term, I take the previous term and I add 2. So that was my kind of English idea. You add 2. So I've translated that to difference equation. Current term is the previous term plus 2. Again, this is only half. If it's a 1-mark question on an exam and you give this as your difference equation, you will get a big old goose egg 0. You haven't given a difference equation. You must have a starting point as well, because there's millions and millions of sequences that are defined by this rule, but only one that starts at 3. So I'm going to specify T1 is equal to 3, and then just being mathematically neurotic, and greater than or equal to 1. Okay, so that's how I've defined my sequence. And then here, again, looking what's happening each time in this pattern, 75, 15, 3. Well, each time I'm dividing by 3. So my English translation, you start at 75. Sorry, when I said divide by 3, I definitely meant divide by 5. Okay, so just to be thorough, okay, I'll show this one in the other format. So if you're particularly partial to starting with Tn plus 1, so you want to be thinking next term, not current term, that's fine. The next term is the current term divided by 5. Again, millions of sequences defined by that rule, but only one starts, again, with T1 is equal to 75. You can say T, so you can also start, that's fine as well, starting at 0. This one will have n greater than or equal to 1. This one will have n greater than or equal to 0. So again, we can always write these things in 2 formats, depending on which you like better. So that's the basic idea with difference equations. Of course, we can get significantly more involved, and you'll see more examples like that later.